stuff before. Well, draw a label a picture. Guess what the picture going to look like?
Triangle.
Thank you. It's a triangle. I mean, where does cosine and sine and cotangent and secant, where do these things come from? So the color triangle. You're not graphing the equation, you'll see y equals anything. And essentially the whole graph and label. Graph and label to bring them down. So this is 5.6 stuff. So cosine of some angle theta is equal to 4 over x. Cosine is what over what in a right triangle. Label, there's my angle theta, there's my right angle. Cosine is what over what? Adjacent over hypotenuse. Okay, no. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this cosine, so this is adjacent for, and the hypotenuse is x. That's all you do. That's all I want to see. Draw a picture of that expression, of that equation. Okay. In order to do the last part of 5.6, you're going to have to be able to draw a triangle based upon what we've already done before. It's just kind of going through the review. Now we're going to do more with it, but we have to at least get through this. Cotangent. So first of all, I need the right triangle. Get used to drawing, maybe just draw the same right triangle for now. Label the right angle and label the angle theta. Now, you might not want to go through Cho-Shak-Kao. Cosecant is the hypotenuse over the opposite. Sha, the secant, is the hypotenuse over the adjacent. Cow, the cotangent, is the adjacent over the opposite. If you put SOHCAHTOA above it, the reciprocal of sine is cosecant. Sine is opposite over hypotenuse, so the cosecant is hypotenuse over the opposite. The reciprocal of cosine is secant. Cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. The reciprocal of tangent is cotangent. Tangent is opposite over adjacent, cotangent is adjacent over opposite. You may not want to go through Cho-Shak-Kao. So if cotangent is cotangent of theta is 5 over 3, I can just flip it over. What's the tangent of theta?
3 over 5.
I can make this picture and it's the same picture. It would be the exact same picture as drawing cotangent. So tangent is opposite. There's the 3, adjacent, there's the 5. That is exactly the same as a picture of cotangent. Just like this would be exactly the same picture of secant theta equal to x over 4. So if you were given a picture of secant theta equals x over 4, I probably wouldn't draw this. I would flip it over and change the cosine equals 4 over x because I understand making the connection to adjacent over hypotenuse a little easier than making my brain flip around it. But if you can, you can't. My brain's not that flexible anymore. At most. You're gonna get stuff that looks like over 30. But we're doing the same thing. I'm not gonna make a picture of cosine. Nine over x plus 3. So I'd write like that, make my picture. Theta. Sine is 2 over what? Opposite over hypotenuse. So this is the 9. Hypotenuse is x plus 3. One more thing before we move on from here. Oops. Yes, I didn't have to understand. Thank you. Eight. 5 plus 3, that's how you get the hypotenuse of a right triangle? No. Didn't think so. What? So, how are you getting that?
Well, 5 times 5 and 3 times 3.
So 25 plus
Plus 9
is 34. But you're closer. So it's not 36, so nothing's 34. So what?
5.83.
So let's just say the square root of 34.
Oh,
X squared, the hypotenuse squared, is equal to the leg squared plus the other leg squared. Wow, my hammer is approaching. It's so bad I couldn't even spell it. X squared equals 5 squared plus 3 squared. So x squared is equal to 25 plus 9. X squared is equal to 34. Take the square root. X is equal to the square root of 34. Because who knows, maybe in this triangle, you have to do what is the sine of theta. So if you're asked now, what is the sine of theta? Like we did in the last chapter, it's opposite over hypotenuse. It's just 3 over square root 34. So this is the next level. What is this side equal to in terms of what you have, in terms of x? That means you got to start with what's this side equal to? Oh, I'm going to use, instead of y, I'm going to use z. Solve for z. What is z? Based on what you have. Here's the thing. A squared plus b squared plus 4 squared equal to q squared. What does a equal?
A equals, uh.
Well, that's supposed to help you figure this out. That's how you're gonna, figure this one. Kind of like a roadmap. You put it in your GPS, it would show you that. Now, I don't mean just this to sound sacrilegious at all, but if you don't open up the Bible, that would say that's your path to salvation. Math out.
Would it be 4 subtract from the cube?
Just a 4.
It was minus 4.
You minus 4, just a cube and a 4. You're close. You're very, very close. You're just doing horrible algebra. And that is exactly when I was teaching AP classes. I would tell them your calculus steps are great, your algebra sucks. Because they were so good at algebra, they never bothered studying algebra, they just passed tests. They could do the test, but then they never actually let it sink in. So what you're saying is you're subtracting 4 squared, and you're going a squared is equal to q squared, q squared minus 4 squared, and then of course you got to take the square root. So you're saying that a is just equal to square root is just a q minus 4.
Oh no. Didn't you?
Is that? But that's what I'm hearing. That's what I'm hearing. And that's not correct. Nope. That's what they nope. Because I'll tell you right now, if I had, let's see, if I had the square root of 100 minus 64, which is technically the square root of 10 squared minus 8 squared. You're telling me that this is just 10 minus 8, because you take the square root of 10 squared to 10, square root of 8 squared and 8. So this is just 2. Well, you know for a fact that 100 minus 64, that's the square root of 36. And what's the square root of 36? So it can't be a 2 one way and a 6 another way. Which way do you think it is? Is it a 2 or a 6? It's a 6, because you have to do what's inside first. You actually have to complete what this is and then take its square root. You can't split up. You cannot do this. This is the big note. You can't go square root of 10 squared minus square root of 8. You can't do square root of each one. And that's how you're getting what you just got. But here's what's going on here. Where? I'm just doing this one. So it's 4 squared plus z squared equals x squared. So how about we just call that 16? 16 plus z squared is equal to x squared. And we're solving for z. We're going to subtract 16 from both sides. And we get z squared equal to x squared minus 16. And then you take the square root. We take the square root of those things. And z squared is equal to, this is all you can do. This sine z is just the square root of x squared minus 16.
Because you don't know what X is.
Now, it's not that. Well, technically, I'm not going to get a number because I don't know. I don't know. Okay. If I knew what it was, I would actually get squared and subtract it. 16. But it's not, x minus 4 because square roots only undo actual perfect squares. It can only do an actual perfect square. X squared minus 16 is not a perfect square. The square root of x squared minus 16 is the square root of x plus 4 times x minus 4. That's not a perfect square. They're two different things. If it was the square root of x plus 4 perfect square, then that's just x plus 4. Because it's a square root of a perfect square. But this is not a perfect square. It's two different factors. So what can you do with it? That's it. You're done. And that's part of 5.6, and that's what you got to get used to. It's there. That's what I'm doing right now. So along comes number 3. And let's solve for this side, z. So here's the deal. In mathematics, we have stuff that looks like this. And we have to set up some kind of equation, some kind of a derivative or integral that involves something like this. And we can't do it based on the algebra that it's in. So we convert it into trigonometry. We convert it to sines, cosines, tangents, which has its own rules. And the way we convert it is through these triangles. So when this is an x plus 3, I should be able to write this in terms of x. What is this side in terms of x? So what is everything in terms of at least an x? So that's a 9, that's what it is. This side, well, we're told it's an x plus 3. So what is this side? Basically combined with an x plus 3 and a 9, and it's a right triangle. What is this missing side in terms of what we have? So let's do that. So let's actually let me expand that way. You were given cosecant theta equal to x plus this over 9. And we came up with this triangle based on that equation. Here's theta. This is 9. This was our x plus 3. That's all. The next question you might have is, what is the cosine? Find cosine theta. Well, if I'm going to find cosine theta, I need adjacent over hypotenuse. And I don't have the adjacent. Well, when it was just numbers, we used the Pythagorean theorem to figure out what had this inside. If I know two sides of a right triangle, I can find the third. So if I have two sides of the triangle, I'm going to figure out which is the missing side. I'm going to use z just to hold that little place right there. And right now, I'm looking at the cosine of theta is equal to this z over the n plus 3. And now I just have to figure out what is z. Z squared plus 9 squared equals parentheses x plus 3 squared. Base squared plus x squared equals hypotenuse squared. So z squared plus 81 is equal to x squared plus 6x plus 9. Oh, wait. Everybody's good with that? How'd you get to? Everybody's good? Everybody remembers their algebra?
I just forgot to do the shortcut.
Well, you don't have to do the shortcut. You can FOIL it out. I'm old. That's all I know. But I'll show you how to FOIL it out, but just want to make sure that that is not a shock to the system. Okay, all right, good, yeah, okay. Because I better not see, x squared plus 9. Because then I gotta go find your algebra teachers at SMAC. X plus 3 times x plus 2. So now solve for z squared. We're going to subtract 81 from both sides. Subtract 81 from the constant. And we get z squared equal to x squared plus 6x. 9 minus 81 is negative 72. Oh, square root. D is equal to the square. Now, if that's a perfect square, then I can take something out of the square root, but it's not a perfect square. If I factor this, this would be x plus 12 times x minus 6. It's not a perfect square, so nothing is going to come out of that square root. The simplification of this expression is, you're looking at it, x squared plus 6x minus 72. So the missing side is the square root of x squared plus 6x minus 72. That's all you can do with it. That is what it equals. But that is a secret. That is what it is. My dad's middle name was Chica. I don't understand. How's his name? His middle name was Chica. But that's his middle name. That side is square root x squared plus 6x minus 7. It doesn't look like, well, it looks like this is. So now the cosine of theta is just that z over hypotenuse. Looking at a test question, not the full test question, but the result of the test question.
So I have a question. So the subtraction at the end, last one, where it says minus 72 and then minus 16, would that tell you that it wouldn't be, you couldn't square it off, or you couldn't, in fact, what's it called? You couldn't make it into a smaller, number? Is this,
Because it's subtraction, in fact, if it's addition or subtraction, you can split the square root. If I had the square root of, square root of 9 plus 16. We already did 100 minus 64. You can't split that into two separate square roots. If it's 9 plus 16, this is the square root of 25. That answer is 5. It is not square root 9 plus square root 16. Because if I do this, that's 3 plus 4, I get 7. I can't have two different answers, which means this is not right. You're supposed to do what's inside first and then take this. You know why? That's a parenthesis. Square root of 9 plus 16 is a parenthesis because it's an exponent. The square root of 9 plus 16 is 9 plus 16 to the 1/2 power. A square root is a 1/2 power, and you're supposed to do what's in the parentheses first, 125, and then 1/2 power is your square root. So therefore, you cannot just split square root 9 square root 16. Okay. And if you do this, it's like, I understand how the 10 square got out, the way you wrote it. I understand how the 64 got, square root got out. Well, how in the world did the negative get out? Who wrote the negative out of the square root? Does it just get a free pass? Somehow you took that negative and just put it in between just because you wanted to. I don't know, system of a doubt to get away with it because you wanted to. All right, you got a quiz today, so now turn it over to you guys. If it's from any of the quiz preps, you have one problem. It's either, for half of you guys, it's going to be a sine, and for the other half, it's going to be a cosine. Please send me a sine, please send me a cosine. And then the bonus question would be a tangent. Yeah, half an hour to do that with 2 problems. So we That's my assumption. Just waiting for somebody to call me on, before we got,
Number one from, track number 3.
number three. So is it ready for us to start taking it apart? You know, sign A, B, and C's, all that stuff. Are we ready to start taking things apart? No. We have to factor out what? Higher report, good. So the first thing is you gotta make sure it's ready for service. We want to find y equals a sine b parentheses x minus h and then plus k. So higher report is gonna come out. So it's gonna start looking like this. Y equals -3 sine. We know it's gonna be pi over 4 times x. You're gonna have x here, it's still gonna be plus. So when you factor out that pi over 4, we get it, that's how we get the x, that's how we get the plus. But if you have to, and if you don't see it, it's this pi over 2. Will you write what I'm trying to think of? Take the pi over 2, you're going to divide by the pi over 4. Okay. Sorry, I'm not. At least that's what the doctor said. Pi over 2 is going to get divided by pi over 4. So that's pi over 2 times 4 over pi. This is a 2. You don't have to show all that, but that's how you get it if you don't see it. If you have to meet the way you do. Does it make sense? When you're factoring out a fraction. If you're factoring out a fraction like this, you're dividing it, so you're multiplying by that fraction's reciprocal. Whenever you're factoring out a fraction, you're divided by its reciprocal. So now the list is A is a -3, B is a pi over 4, C is a what? Sorry, C, H is a what? -2, and K is 0. Amplitude, absolute value of A. So absolute value of -3, the amplitude is +3. Period. So the period is 2 pi over b. So that means we have 2 pi over pi over 4. So again, we're dividing. So that's 2 pi times the reciprocal 4 over pi. So what's going to reduce? Pi. The pi will reduce, so we end up with
2 times 4 equals 8.
So we end up with 8. Now, here's where I hope you look at the graph. Look at I'm going to supply you with the XY axis and look at how the XY axis is laid out. First of all, there's no pi on the XY axis. So your period should have no pi's in it. It's just number. Integer. So if you end up with a pi here, there's no way to put a pi in there. I wouldn't do that to you. Okay. And also you see how it goes from at least 8 in distance. This is from -3 to 6. That's a distance of 9. So a period of 8 would fit one oscillation. You're welcome. What is H? H is negative 2. This is 2 pi over b for sine cosine, secant cosecant, absolute value A. Vertical shift is K. What's our vertical shift? 0, because K is 0. And sine cosine, the answer is none. The word none. Don't leave it blank. Don't put a 0. Don't put an empty set. You write the word none. Just always. It's just over top. And then, so they do another group. And then here comes the test. But you learn what you learn your. Do it again. Okay. Now, whether you draw little thumbnails to get there, that's up to you. If you do, it helps you learn how this thing actually works. So it's a sine. Y equals just simple sine x, which would look like this. Starts at 0, 0, and goes up, it goes back down, it ends at 2 pi. This is equal to a 1, that's a negative 1. Now, I'm just going to put in the change to the amplitude. It's a positive, well, it's a negative 3, but I'm going to have to just put positive 3 for now. I'll hold on to the negative in a minute because it's only drawn out. So this would be 3 here instead of a 1. And then b is a pi over 4. So we're going to put a pi over 4 in there. We'll put a pi over 4 right here. And that changes the period to an 8. So instead of 2 pi, that's now an 8, which means this is 4. This right here is what? 2. And in between 4 and 8, 6. So I got some numbers to work with. Now let's put a little bit more together. The only thing missing is the negative, so we're going to draw the next thumbnail upside down, and then we're going to look at the shift to the left. Negative. So if it's going to be a negative, it would start here and go down and then come up. And this would still be 4, that would still be 2, that would still be 6. This would be negative 3, that would be positive. And the only piece that I haven't taken into account is a +2. When I put the +2 in, the shift is 2 to the left because you see a positive here. So everybody is going to pack up their bag and we're going to go 2 to the left. So you're going to go 1, 2 to the left. You're at 0. You're going to end up over here, 2 to the left. So this point is going to start here. It's going to be right there at that -2. So I'm looking at individual points, 5 of them, and I'm going to slide them to the left. The next one would be the minimum. This minimum happens at 2. When it goes 2 to the left, where is it going to end up? At x equals where? At 0. So it was at 2. 2 to the left is not going to put it at 0. So it's going to end up at 0, -3. This x-intercept happens at 4. So instead of crossing the x-axis here at x equals 4, we're going to move you 2 to the left. So you're now going to intersect the x-axis where? At 2. Now, take a look at our symmetry. In between this x-intercept and the minimum, you have 2 rectangles, 2 numbers, 2 slots. So between here and the next intercept, you should have two slots, 1, 2. For symmetry. So you know what? You can actually go, hey, in between here and the maximum, I should have two slots. So the next point should happen at 4. And if you look, the next maximum was at 6, and if you slide it over 2, it's going to happen here at 4, at 4, 3. And here was 8, and that slides this way too, so the x-intercept is going to be at 6. And now, nice and sweet. Here's what I can only tell you what I see in the past. This is not the graph. That is not a sine curve. It's not even a curve. Draw a smooth curve. When I see a quiz like that or a test like that, especially when it's from the take-home part, it's like you didn't take the time to just. You could even be looking at the videos and see me say, please don't draw those straight line. And since the number line is already labeled, the labeling's been done.
Why is it important that they're not straight lines?
Because if you draw a straight line, those points that make up that straight line are not coming out of the equation. When I plug in x equals -1, it's not going to be there. X equals -1 is going to be a value on the curve down there. That you wouldn't plot that. So like right by, no, let's see, what would you mean 1/2? So sine of pi over 6, so pi over 2, pi over 2 minus pi over pi over 3. When x is equal to negative nine. Yes. So if you let x equal 2 pi or 2/3, when x is 2/3, we get an actual 1/2 value. Now 2. messing up. But you caught me right now, but yeah, it's not gonna be on that straight line.
In the next chapter, are we gonna get things where it's like in between the profiles or that?
You mean in between on the curve or in the, yes. Actually, in the next chapter, we're gonna be solving equations and having a ton, we're like, it's what? It's 16 formula, trig identity.
Okay.
Where you can solve an equation and you can have as many as, well, 12, 13, 18 solutions.
Number 2 on the same one.
Okay, is this one ready to go? Is it in the right form?
Yes.
Okay, it's already been factored out. There's a cosine. So y equals a cosine b parentheses x minus h and then a plus k. And everything matches up. We don't have to do any factoring, so everything's good. A is 3/2. B is 2. C, or keep saying C. H is positive 5/3, and K is -1. So amplitude is changed. Instead of a 1, it's 3/2. The period is changed. Instead of having one oscillation from 0 to 2 pi, it's going to have 2 of them. The horizontal shift is going to go right or left.
Right.
Going to the right because H is positive 5/3, so we're going to the right 5/3. And the vertical shift, we're going to shift that thing up or down.
Yeah.
Down 1. Okay, so those are the things that are happening. Amplitude, so absolute value of A. I keep writing that just because there's always favorite formulas. Absolute value of 3/2 is 3/2. 3/2 goes, and then period is equal to 2 pi over b. And 2 pi over 2 is just 1 pi. So horizontal shift is just the h, which is pi over 3. And the vertical shift is just the k, the k is -1. And for sine and cosine, asymptote is none. Are you feeling focus over there?
Yeah.
So black.
We did a little comparison, and it seems to show up better when only these are shown. I will try to make the projector maybe a little brighter. So we're graphing cosine. So y equals just cosine x. So cosine starts at 0, 1. It starts up here at 1, and then it comes down, and it goes back up, and it finishes at 1. Normal period is 1 pi. Or sorry, 2 pi. What's in the middle? 1 pi. What's halfway? Pi over 2. And this would be 3 pi over 2. So this is the normal cosine number. Down here is negative. So the first thing I'm going to look at in terms of change, A is actually 3/2. So the amplitude is 3/2. So instead of a 1, this is now 3/2. This would be negative 3/2. And over here, 3/2 would be here. And the period's been changed. There's a 2 in front of the inch. So that changes the period to 1 pi, not 2 pi. That's a 1 pi. This would be half of that. What is,
Power 2.
that's pi over 2 then. And this would be half of 0 to pi over 2. Pi over 4. And this would be halfway from pi over 2 to pi. So that would be 3 pi over 2. So those are the numbers if it was just those, just a change in the amplitude, change the period. So now we have to shift it. And we're going to do x minus the pi over 3. So that means everything that I have is now going to move pi over 3 to the right. So instead of starting at 0, this point is going to start at pi over 3. Now, pi over 3. If you look at just a quick number, here's 0. Here's pi over 2. In terms of our special angles, you get your 0, you get your pi over 4, your pi over 3, 2 pi over 3, pi over 6, 5 pi over 6. Which one is the one that's closest to 0?
Pi over 3. I mean, pi over 6.
It goes pi over 6, and then it goes
Pi over 4.
pi over 4, and then it goes
Over 3.
pi over 3. So this point is actually going to move here to pi over 3. That's how far pi over 3 is going to go. So on this number line, look at how the little tick marks are. This is pi. Here's pi over 2. This is pi over 4. Right here, pi over 6. And right there's your pi over 3. There's your pi over 4. There's your 5 pi over 6. There's pi. And remember, everything's going to go pi over 3 to the right. So that means this point has got to go pi over pi over 3. That's just pi over 6. That's just pi over 4. So you're going to go all the way to here when it finishes. This is 7 pi over 6. This is equal to 5 pi over 4. And this one is your 4 pi over 3. That's the full pi over 3 to the right. So instead of having to try to do all of these, hey, you're going to go over pi over 3 there, you're going to go pi over 3 that way. Everybody's going over pi over 3. Here's what I'm going to do. In my picture here, it used to be here. We're going to go pi over 3 that way, right straight across from 3 over 2. So it's going to be right here. It would be right here because we started with one more thing. And then the 0 will hit pi over 4. I need to go pi over 3 to the right.
That's
Pi over 4 plus pi over 3. All right, you can start adding fractions and doing the whole thing. How many little squares did I move? 1, 2, 3, 4, 5, 6, 7, 8. I just got to move this point. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right here. And it's going to be that 0. That's what it would be. Basically, pi over 3 is 8 little squares that I'm moving. This one's going to move 8 little squares, pi over 3 to the right. So it wasn't negative 3 over 2. And that was at pi over 2. And we're going to move 1, 2, 3, 4, 5, 6, 7, 8. And that makes sense because if I go 1/3 to the right, I should end up at 556. And then when this one goes 1/3 to the right, it's going to end at 453. So the toughest one, I guess I need the middle here. I didn't move this guy. So 3 pi over 4. 1, 2, 3, 4, 5, 6, 7, 8. You were right there. You're no longer here. Don't forget, you still have one last thing to do. What's that? Vertical shift the suit. So that is, K is, so everybody's gonna go up 1, down. So now I just gotta drop everybody down. Everybody go down. Power 3 to the right and then downward. So instead of you being there, you are now gonna go drop down from 3 over 2 to what? They drop down what?
Just to 0.5.
To 1/2. So this -1. Right there. This used to be a -3 over 2. So when I drop it down 1, it's going to be a -5 over 2, which is 2.5. So, and then that's going to go down to -1. And go under there. And you've got to drop down to 1/2. And we're there. And so it now starts. A little curve to here. And then a little curve to there. Another little curve. Another little curve. Well, that's a problem. Unacceptable. Mathematicians, you do need a little OCD. But again, you're not going to, no one's taking the calculator away from you. You can enter that into the calculator, provided you know how to use it. You've done something with it before now. You can type it in, you can, set the window to represent that scale. And then you know exactly where it should go, and you just got to make sure you plot what you need, those 5 points. Answer those 5 questions, that's on you. Calculator's not going to answer the questions for you. All right. We'll come back at 11:30. We got to finish 5.6.